Hello everyone, welcome to my channel. I am Akash Avasthi and I am making my first model rocket. I'm making my first model rocket which will go around 1000 feet high. So here is my rocket. In this video I'm gonna tell how I made this and what things I'm using. We'll go in detail as well. So let's get started. So first thing first, I am using the PVC pipe for making my model rocket, and it is weighing around 1.2 kg. It is having a parachute ejection system and active fin control actuation. It is also having a flight computer inside. Sorry. So the actuation is servo controlled and everything is servo controlled. So I face certain difficulties while making it. So let's go deep into it. The first problem with me was its nose cone. It is having cardboard inside and I'm using black tape for its covering. It is slightly rough as you can see, although it will affect the aerodynamics as well, because I don't think so it is completely straight and or the tip of the nose cone is at perfect center. Then for the parachute ejection system, because I was not having my 3D printer, and therefore I permanently fixed the nose cone. Made it difficult for me for how will I eject the parachute, this parachute. So I decided to cut a small piece from the tube, and the servo will open this fairing and parachute will eject out. Also I am using small magnets over here, as you can see. These help me help the fairing to get fixed here. So while I was fitting this parachute inside the rocket, I got another idea. Like, why don't I attach something here with the motor such that it is, when it will open, it will take the parachute out like this. Now you might be thinking why don't I attach the parachute here such that if the this motor opens the cap, this parachute will automatically get out, but I can't do it because this servo motor can't take such loads. So I think I should attach something here with the motor such that this is the parachute here, and this is closed, but when it will open, it will also take it like this. So now I have decided that I will attach this piece of cloth, I will cut this part and attach one part to the fairing while the other part will be attached to the body. So the parachute will be here, here let's assume here we have the parachute. So I have attached this part to the body and this part to the fairing. So let's imagine it's closed. So when the fairing will open, it will the cloth will stretch and take out the this parachute like this. So I think it will work. Let's see what happens next. Here. So now I think it will work Like as you can see, it is up, and when I put it down, it will go down like this. Oh, I think it will work, but I can't predict. I think it will work. So let's try again. I have changed the code, like it was opening and closing after 3 seconds, but now I have changed the code. So let's try again. Oh, working fine. Ah, like it's struck till like it's struck here, but when it will fall down, it will automatically like turn out. So I'm done with the parachute ejection system. So let's move to the next part. So let's come to the fins part. So in fin here you can see these are made of PVC panels, and servos are installed. Uh, for the airplanes these are called rudders, but I don't know for rocket whether what they are called. But still we can say these are the rudders. So the here inside we have the flight computer. This flight computer, what will it will do that it has gyroscopic sensor that will sense the orientation of the rocket, and based on the signals from the sensor, the servo will actuate. This is completely immature rocketry, and these fins are also not aligned properly with this tube, which I think can make my rocket difficult to reach its orbit. Oh, sorry, the altitude, required altitude, but still hope for the best. So let's come to the flight computer. Like you can see here, I have designed my messy flight computer with lot of wires. This is my first prototype, uh, and I'm going to use this in my first rocket. In my coming future videos, I will upgrade it. I'll use 3D printed bay for it. But now, as you can see, I am using Arduino as a microcontroller. It has two Arduinos. One is for this fin actuation, while the second is for data storage and parachute ejection system. So it is having two gyro sensors, one with the fin control and second for the orientation for the parachute ejection system. And other sensor is barometric pressure sensor, which will measure the altitude of it. When it will sense that after reaching maximum altitude it is coming down, then it will automatically eject the parachute. I have tried hard making my flight computer, but again and again the wires were breaking down, the connections were loose, and everything like I was thinking like I was thinking like इससे बुरा क्या हो सकता है, and इससे ही बुरा हो जाता था. So this is basically what I am doing. For the propellant, I am using sugar-based propellant. That is sugar and potassium nitrate. So after I finished making my fins, I struck with another problem. The problem I got was I was unable to fit my fuel motor inside because the servos were obstructing from the inside. So I was not getting how to rectify this problem. So without 3D printer, it was making me difficult to make some washers so that these servos could be moved more toward the outside, so that the fuel motor could be fit inside. But then I found something. So first I got a wooden base from my storeroom, and which I thought it will work, from which I could make the washers. But as you can see, it didn't work. As it was having, it was like while drilling, it was cracking up. So this plan was dropped. But then I found my old pen refill. So I have to cut these refill into small pieces on the required length, so that it could make the servos move toward the outside. Now it's done. So I am happy with this. For the fillet, I have used my glue gun. And for the software, I am using the Open Rocket software, through which it helped me in designing my model rocket. The physically I made it here, and with the same dimension I designed, and with the same dimensions and mass I designed it in the Open Rocket software. So it was helping me in deciding where the center of mass and the center of pressure will lie, and what altitude it will reach based on the built-in motors data which was in the software inside. I was using another software for making my sugar propellant, which is the open motor, which we will discuss it in the next videos, because in the next video I'm gonna tell how I'm making my fuel motors, and how I'm making the test bench and this launch pad. I'm working on that as well, but currently in this video I was here to tell you only about the rocket. So for watching more videos, please like and share it to your friends. Also subscribe to my channel, and that's it for today. And thanks for watching. Jai Shri Ram.